Today we are going to take a look at building off of what we've done in class and come to more of an agreement and a set way of how we're going to look at dividing fractions. Before we get into that though, I just want to review really quickly some of the things that I've been mentioning in class about the different types of division. So as you're working through this, you'll see that we're really kind of working with one type of division when we are dividing fractions. In elementary school, most of the time you were probably doing what was called partitive division. And in partitive division, this is the type of situation when we are sharing fairly to make sure that everyone gets the same amount. So this would be a situation if we look at this group of cookies. What we have is we look at the fact that we have 12 cookies and we want to divide those cookies among, say, our 6 friends to figure out how many cookies each friend would get. So when you're younger and you're first learning about this, you might draw out your friends, or you might name 6 friends, and then you might actually take each of those cookies and just take them one by one and split them between your 6 friends. So we would end up with, like, here's friend number 1, friend number 2, 3, 4, 5, and 6. And so then each friend would end up with 2 cookies if we kind of take them like one by one to the different people. So that's partitive. The second one is called measurement division. And this is when we make groups of the divisor. So now instead of figuring out how many go into each group, we are figuring out how many groups we can make. So really what we're looking at is how many times can we fit the divisor into the dividend. So in this type of situation, we might say something like, okay, so we baked 12 cookies and we are splitting it into groups, and we'll say that in this case there are 2 cookies per serving. I'm trying to think how to write it, or how to label it. So we have 12 cookies and we want to put them into groups of 2 because the serving size is 2, and we want to know how many groups we can make. So in this one, what we would do is we could go in with those different colors and kind of circle and be like, okay, there's my first group. Here's a second group, third group, fourth group. I ran out of colors, but you kind of get the idea. So we're sitting there and just using those different colors to show those different groups. Now in both cases, so if I had said like groups of 6, so here we would end up with like 6 groups or 6 servings that we end up with. You might say, well, what difference does it make? You kind of could end up with the same type of answers. It just changes our understanding and how we are modeling those a little bit. So now let's kind of look at some actual problems that involve fractions. Antoine is having a birthday party. His parents said they would buy 4 pizzas for the party. So Antoine wants each person to eat 2/3 of a pizza. So we'll think that's our serving size. So we want to know how many servings does Antoine have available for people at the party. So visually what we're looking at is, drawing out what we have. So in this case, we have 4 pizzas. Since Antoine is giving each person 2/3 of a pizza, we're going to take each pizza and split it into thirds. So at this point, our mathematical sentence is I have 4 pizzas and I'm dividing it into groups of 2/3. So this would be that measurement division because we're measuring out 2/3 of a pizza at a time. Now we could use different colors or we could sit there and name people. So we could sit there and be like, okay, so first Antoine comes up because it's his birthday and Antoine takes 2 pieces of pizza. And then maybe Mom comes and Mom is going to take 2 pieces of pizza. And then maybe Dad comes and Dad takes 2 pieces of pizza. And you can keep going. So we'll say maybe Michael came to the party, or like Hyde came to the party and Hyde takes 2 pieces. And then maybe Joey comes to the party and Joey's going to take 2 pieces. And then Riley comes to the party and Riley takes 2 pieces as well. So now we can look at what ends up happening is when we split that, those 4 pizzas actually changed a little bit in the fact that since we cut them into thirds, that 4 really becomes, there's 12 pieces of pizza available, and each piece of pizza is a third of a pizza. And then we're putting them into groups of 2/3. And now if we go through and just look, so we have 1, 2, 3, 4, 5, 6 servings. Here we end up with an answer of 6/1 because there's 6 complete servings, or 6 servings of pizza. Now what you may have noticed is that on the bottom here, we actually ended up with a common denominator. We'll talk a little bit more about that as we're going through. Let's look at a second problem. Nikita has 2.5 pints of ice cream in the freezer. The serving size listed says that it's 2/3 of a pint. So we want to know how many servings of ice cream does Nikita have. So how many times could Nikita have ice cream if she's only eating the serving size every time. So once again, we're going to start with the visual. So I would encourage you to kind of pause the video, maybe try this one on your own and then check. So here, this one's a little bit different because we're not dealing with full amounts. So what I'm going to do is we have our 2 full pints, and then I'm just going to kind of like shade in this other part because we're not going to use that part of the visual. Now we're going to take 2/3 of a pint. So kind of like what we did before is I'm going to go through and cut my pieces into thirds. Or my pints. Now you may notice that when we get to this third circle, it's not really easy to cut the full pint into thirds because we don't have the full pint. So this is where that common denominator piece kind of comes in. So what we started with is 2.5 dividing into groups of 2/3. Now, for ease of what we're doing, it's going to be common for us to change mixed numbers into improper fractions like we did when we multiplied. So that 2.5, we're really going to say that's really 5 halves because if I count if I would count pieces, right, I would have 5 halves total, or 2 times 2 plus 1, dividing into groups of 2/3. If I look, 2 and 3, a common multiple of both would be 6. So I'm going to change each of these into sixths, which means I am then going to go in and actually take my pints and cut those into 6. So now each third is going to be cut in half, or if I have a half, it's going to be cut into thirds. So now instead of taking 2/3, we're going to take, if we look, we now have 15 total pieces. that each represent a sixth, and we're going to put them into groups because I'm creating a common denominator. So like multiplying by 3 for both of these, and then this is going to be multiplied by 2. I'm going to put them into groups of 4/6. Once again, I can use my visual, so I can go, there's my first serving. Then Nikita comes in and eats the second serving, the third serving. So we were able to eat 3 full servings. But if you notice, when we go to that last part, there aren't enough pieces. There's only 3, but we need 4. So this comes back into that part that we were looking at, like what part is it? So here it takes 4 pieces to make a serving, but we only have 3 pieces left here. So when we do this division, it ends up being 3 full servings and then 3/4 of another serving. Or if we kind of look at that common denominator, and this is going to look really weird, is we end up with 15 divided by 4, but 4 can't go into 15 equally over 1, because we're going to, those denominators kind of stay. But really, whenever we divide by 1, this part just kind of goes away. And so we're really just looking at 15/4, which 4 goes into 15 3 full times with 3 left over. I know that's a lot, so if you have questions about it, we're going to go through this in class. But make sure that you just kind of reach out and ask questions. So a quick just summary. When we're dividing fractions, one way we can do that is by using common denominators. Is just a quick way to find those equal pieces like we did in the model. Just like when we multiplied, we are going to go ahead and change all mixed numbers into improper fractions. And then we can actually just divide across. So as one more example, something that isn't linked to a word problem, we just want to divide 1/3 by 3/4 using our strategy. So with 3 and 4, a common multiple or common denominator would be 12. So I'm going to take both of these and turn them into 12, so I have to multiply the top and the bottom by the same number. So the thirds have to be multiplied by 4, so this becomes 4/12. And the fourths are going to be multiplied by 3 to make 12. So this will become 9/12, and we're going to divide across. So if you do this properly, 12 divided by 12 is 1. Your denominator is always going to be equal to 1. And so when we look at it, it kind of cancels itself out, so we don't have to worry about it. And here we're going to kind of skip this step because I think it just confuses people. But just know that it's actually there. So in the end, we end up with just 4/9 as an answer. So in this case, we can't even make a full group because we only have 4 pieces, but it's going to take 9 pieces to make a full group. I will say, just as kind of a side note, many of your parents are probably going to have a different procedure that they typically use for dividing fractions. There's nothing wrong with that procedure. It's just one that commonly creates a lot of errors when students use it because they don't necessarily understand how or why it works. I'm not opposed to people using it, and we'll talk a little bit about it in a future lesson, so just kind of keep that in mind.